OK, so basically, as told, I'm going to talk about Graal. And the whole point of this first part of presentation session is basically to onboard everyone onto what the Graal is, why the hype, and that kind of thing. So yeah. I want to start by talking about something very, very basic, which is basically something we as developers do every day, which is deploy code and write code. So the regular flow is, you write code, whatever JVM language you use, then you compile it into a bytecode, and eventually it gets into JVM, which executes it. And to execute it, it needs to kind of compile it into native code, right? And just for the sake of this presentation, I'm going to simplify it even more and basically say that everything is an array of bytes. So basically, you write one kind of array of bytes, then you turn it into another type, and then finally, JVM turns it into native code, which is also an array of bytes, essentially. So the JVM part is the two latter ones. And actually, you can even split JVM into more pieces, which means that you have the virtual machine itself, and you also have the compiler, which usually is C2. And actually, both of these are written in C. And it's a huge, actually, it's very important that it's written in C, because Oracle released a while ago. Actually, you can see that it happened in 2014. They released this proposal for Java-level JVM compiler interface. And just to sum it up, it basically means that it's an interface which enables compiler to be written in Java. And it's a very important thing here. The motivation itself, just short version is writing a JVM compiler in Java should allow production of a high-quality compiler that will be easier to maintain and improve than existing compilers developed in C. So basically, they had a bunch of legacy C code nobody really wanted to work on. So they decided, let's do it in Java. And that's the essence, basically, behind the Graal, right? So the Java-level JVM compiler interface is the vertical line, basically, with the separator between the virtual machine and the compiler. So Graal, at its core, is just a rewrite of the existing Java compiler, which sits inside the JVM, which basically compiles bytecode into native code. But when I first heard about it or realized it, that it's it's just a compiler rewrite, I really didn't care. I think many people don't get to experience or interact with the compiler directly. We just run it on JVM. So the only thing that we might want to know about Graal as a compiler is performance. And that is partially the reason why it got so hyped. Because a while ago, I think the main thing was that Twitter said, OK, we tried Graal. It actually performs better. They said that it's like 11% out of the box. They tweaked it a bit. It became like 13. And actually now, Oracle says that Twitter saves like 25% CPU just by using Graal. So I'm not sure what the number is correct. Because, for example, when we did benchmarks here at Twix, the results weren't that clear. Sometimes it's faster, sometimes it's slower. It depends. And actually, there are a couple, at least, blog posts about people trying Graal and finding that it's actually slower. So, I guess it depends on the use case, because there are definitely some use cases where it's just faster. For example, if you use a lot of streams, Graal is amazing there. It optimizes it really well. And of course, Twitter also talked about fewer GC cycles. So again, it's a bit faster. And basically, that's the thing why it got so popular, at the beginning, I would say. And an obvious question is, OK, so it's faster, I guess, more probably. Can I use it? And the easy answer is yes, but you only have to use those flags for your JVM, because JDK 9 and up come with Graal by default. I mean, like, it comes with Graal. It's default for ahead of time compilation. But for JIT, you need to actually enable it with the flags, which is not hard. Or there's a second option. You can just download the GraalVM and use it as it is. It's pre-configured. And now we come to the point where I'm starting to use the term from the actual title, which is GraalVM. And it's not the same thing as Graal, but there are many people confusing those two. So just to clarify, Graal is the JIT compiler, basically the compiler, and GraalVM is just a bundle like JVM pre-configured with Graal, Truffle, which I'm gonna talk about later, and a couple language implementations. So basically, GraalVM is the pre-configured fun toy for everyone to use. And also it uses JDK 8 because it's the last stable long-term support version. So they wanted to have something for the enterprise. Yeah, so Graal is exactly the replacement for existing C2 compiler. Not a big deal, you know. Well, maybe it is for certain scenarios, but for me as a developer, like, I don't really care. But Graal itself, like, the rewrite itself is not fun, and it's not something that made me interested in it. And actually, there's another thing that it introduced. So I'm going to move things around here because I want to show where it's placed. So the native code is going to be marked with this native flag. And I'm going to put this chocolate cake on the bytecode. And now the magic happens here. In between of bytecode and the native code, what Graal does is compile it, well, parse it, and turn it into so-called abstract syntax trees. This is not new. Pretty much all modern compilers do that. But the difference is that it exposes it as an API. And basically, what it is an in-memory data structure which, you know, just represents your code in very low level. Like each node is very basic operation, kind of like in assembly, like add, multiply, call, add to stack, that kind of thing. But the thing that, since it's exposed as an API, Graal doesn't really care where it comes from. What that means is that you can compile whatever into these syntax trees, and you can run anything on JVM. So the fun part about Graal is that it's actually language agnostic. And this is the most important thing to understand for tonight, because that's the main part we are going to talk about. And the thing that I already mentioned, Truffle, is actually a framework provided by guys from Oracle Labs so that you can easily implement, or at least relatively easy, implement a new language which can be used on Graal. What it comes with is basically all the regular node types of, you know, add, subtract, call a function, create a new object, that kind of thing, because pretty much all modern languages do that anyway, so you need that. So you have to write a parser. But there is another very good thing in Truffle, which is it comes with a bunch of optimizations. For example, I guess not many people know, but shitty languages use stack for calling a function. It basically puts parameters in, and it invokes the function, then it takes the parameters out, that kind of thing, and the same for the result. But actually, if you want to get really performant language, what you have to do is to play around with registers, and Graal does it for you. It's very hard, actually, to do it properly, but Truffle comes with it out of the box. So for language developers, it's a huge deal. You know, it just makes life a lot easier. The whole architecture kind of looks like this, which is Java hotspot, unchanged. It's written in C. It's still there. You have the compiler interface. You have the Graal compiler on top, which is written in Java now. Of course, you have a kind of shortcut for Java and other JVM languages, which means that Graal understands bytecode. But you also have the Truffle, which actually enables other languages. And for example, it's already implemented by guys from Oracle Labs, the Ruby, R, JavaScript. And also what they did is implement Sulong, which basically means that you can execute native applications in JVM, which is also one of the cool things that you can use Graal for. And I've seen in the past, I know my past is not that long, but I already have seen quite a few solutions for polyglot applications. And to be honest, they all suck. And so my first question was, OK, so it can do multiple languages, but I guess it's still not usable, right? And I'm not going to answer it because it's the topic for Milda, so wait for that. But what I want to talk about next is actually what cool can you do with Graal, or what do people do with it? So this is one of the guys from the Graal team. They go around, make a lot of presentations. This one, for example, is about he's running application on Graal. And if you notice, he's sitting in Chrome. And you can see that in Chrome, you have a stack trace, which is Ruby files. And actually, he's going through Ruby applications step by step. Basically, when you use Graal to run whatever language applications, what you get pretty much out of the box is all the tooling that you have for Java, all the debuggers, all the I don't know, performance analyzers. You have all that already working for whatever language you run, because Graal doesn't really care what it's running, since it doesn't even know where the source code comes from. So in JVM, everything is basically in the same structure anyway. So it just works. It's cool. I guess for Java developers, seeing a Chrome debugging even Java application is not really a big deal because we don't use Chrome. We use it for email or something like that. OK. Another example is the guy goes into NPM module repository. It's a validator. It checks for valid emails, right? Just regular Node stuff. But the fun stuff is that he actually starts running Oracle SQL Server. And if you can't see, I can zoom it in. He's actually running and using that NPM module inside SQL Server. And at that point, I was basically blown away. You can take existing application, you can put code into it. Oracle SQL is native one, and yeah, you can mix and match a lot of things. I don't know why you would put your logic into database, but for me as a developer, it's still really cool that you can do it. I guess in some niche, you can make use of it. So yeah, those are the two examples that somewhat easy to understand. It's fun to see. But there are some more usages that you can think of, or you can apply Graal to. And one of the more realistic ones is that you can use it for legacy applications. I guess most people have heard about some old project written in who knows what kind of language, and nobody wants to work with it. You can use Graal to use it as a core, write your new logic in new language, actually maintainable one, and just run it on Graal. So that's, I think, useful. Also, I've seen a couple, at least, projects which picked language just because there was this one library in, for example, Node that does the job really well. And there's no counterpart in, for example, Java. So people pick Node. They hate Node, but they still do it. with Graal, you don't have to make such trade-off. You just have to, you can use pretty much any modern language library in Graal, which is, again, useful. I guess it doesn't have many use cases because usually you have a lot of libraries in Java, for example. But especially talking about Truffle, you also have this kind of nice thing about language development, which is it just makes things easier for language developers. I personally hope that we're going to see kind of the same situation with language development, what we see with open source, which is people fork stuff. They introduce new ideas. It's relatively easy for them. And they can say, OK, just use my compiler, and you can, I don't know, have really cool JavaScript in your application. And I guess I wish that it would kind of power the whole development for languages. I feel like it's a bit stuck right now. So that's, I guess, my personal wish. Also, something that might happen is actually people might start writing custom optimizations. Like I said, Graal is very good with streams and optimizing them. But you can do a lot of very specific optimizations for very specific applications. Maybe we'll see in the future something like open source optimizations that you can just take and plug into your JVM to make your application run like 10 times faster, hopefully. And there's another more business-related usage for Graal, which is it can actually be used in cloud by cloud providers quite well. I'll start with the, I don't know, like a less useful one, which is, for example, if you go to App Engine and you see a bunch of implementations for Node, for Golang, for Python, for Java, even for Java. I believe Java.IL was not available for quite long because they were spending lots of time developing the new runtime. With Graal, you can use a lot of same runtime for all the languages. So I guess it can be used by providers to kind of get a faster development cycle, I guess. But another thing which is actually being developed by Oracle and what they intend to use Graal for is use it for, I think it's very useful for something like Cloud Functions or very platform for your application. And actually they introduce something like isolation in memory. They argue that Docker, for example, is very heavy. And if you just run everything on Graal, you don't have to ship JVM, for example. You can share libraries between applications and that kind of thing. So this is one of the things that Oracle is actually working on, which is using or developing Graal for that purpose, running JVM as the single kind of container manager for the server. So that's also kind of interesting. At least I find it interesting, yeah. And I already talked that it's easy to start using Graal. Especially for Node, I want to just show how easy it is to use the bundle, the GraalVM, not the flags. So basically, you just go to their repository or website. You go to releases, you download the tar, and you have a bunch of binaries. And that's basically it. You just have to use them. For example, for Node, you put it into class path, and you get this special node with custom flags. You just add like polyglot, and you already have Java working, R working. You put JVM, it's on JVM, you don't put it, It's very easy to use. Like even to mess around, you just have to download it. Like it takes a couple of minutes and you're good to go. You can run your existing Express applications on it, for example. So yeah, thank you. Maybe you have some questions.